All right. So we're doing the 2019 Canadian Computing Competition paper. We are the winning short question. And this question is just a simple addition question. All right. This question is just a simple addition question. What is important with these what's important with these questions is that you have to follow the input specifications just as they say. So these programs, we don't really have too many prompts coming up because it's competitive programming. It's simply they tell you what they want and you do it. So this is what your program's supposed to look like. Your program when it starts up, no prompts come up saying enter any, just the screen, and you know that you have to enter 6 questions. Sorry, six inputs, 6 numbers as input, and you will get your particular output. When you're doing your answer, right? Just make sure that you test back the same information that you have here and get the same result that they get. That's a nice surefire way to know whether your program working or not. All right. So if we jumping into the answers for this, we're looking at doing sorry. If we're jumping into the answers for this, and we're looking at doing the question, of course, we're starting up in our regular C. We could save the file and name it a .c something. So we could name the CCC 2019 Q1.c. Okay. Oh, what has happened to my? I do not feel that is a good sign. Oh, no. Ooh. So my code blocks has crashed. What happened there? All right, let's try again. (2019) CCC Q1.c. All right. I guess these things do happen. All right, so include stdio.h and include stdlib.h. And we have int main, and we start. So now the important thing is for you to remember your what the question is asking us to do. The first thing that the question asking us to do is really and truly to input 6 numbers. The first 3 numbers go to the team apple. The second 3 numbers go to the team bananas. Don't overcomplicate your answer, right? So the first input here represents 3 pointers, right? The second represents field goals, and the third represents free throws. So I would name it, right? I would name it 3 pointers underscore apples. And all of these, of course, are integers. So integers 3 pointer underscore apple, field goal underscore apple, and free throw underscore apple. And then you do the same thing for the bananas. 3 pointers underscore banana, field goal underscore banana, and free throw underscore banana. And that's what we need by way of the input right now. So we only studying our input for now. And we just need 6 scanf statements, because you notice that the way that they specify the input, each thing goes on its own line, right? So that is 6 scanf statements that we have to write. Okay, so we could go scanf, right? %, percent sign D. Okay, and go so fast to put your ampersand there. And in a fit of extreme laziness, oh sorry, let me get chars after all of my scanfs. So that I get where behavior 1, 2, 3, 4, 5, 6, and I just copy and paste these into here. Copy, paste. Everybody with me so far on this question, right?
Yeah.
Yeah?
Sir.
Yes, sir.
All right. And so the next thing that we need is that we need to be able to work out our our scores, right? So we could have total for team A and total for team B. So we have the total for team A and the total for team B. So the total for team A is going to be, right? And you could put it in brackets to make it easier for yourself. 3 point underscore A multiplied by 3 plus field goal underscore A multiplied by 2 plus free throw underscore A, right? Which you don't have to multiply it by 1 because it'll be the same thing. Okay? And you could just copy and paste that and change every A to B here. And it's the same thing. So now you have the total score for A and the total score for B. And now if we go back here, it's just simply now a matter of who scored more. Is it A is more, B is more, or they have the same amount? So that's a simple if statement. Anybody want to walk me through this if statement? Guide me, somebody.
So you could say
Mm-hmm.
if total underscore A is greater than total underscore B, well, you have to print out what they ask. And I can't remember what they ask. I think is some kind of thing. I can't remember exactly. And else, if
They
it's not,
say,
well, you print out.
the output will be a single character. If the apples score more than the bananas, output A. If the bananas score more points than the apples, output B. Otherwise, output T to indicate a tie. So my output is just A, B, or T. So if total underscore A is greater than total underscore B, then it means that we can printf single character A. Else if total underscore B is greater than total underscore A, then we output a single character that just goes B. And else we could just output single character. And now we can run this and test it and see. When we compile, we have no errors. So we run it. We know that the original question gave us 10, 3, and 7, 8, 9, and 6. Right? 10, 3, 7, 8, 9, 6. So we have 10, 3, 7, 8, 9, and 6. And the answer here is, and that's my solution there. This is according to the specification what they wanted. But my thing is, always test twice. So test twice. So let's take this next sample input, which should give us a tie. 730641. right? 730,641. 730,641. And that's a tie. According to the specification, this was a tie. Right? And they give us the example down there. So is that fine? Anybody feel like they could not do this question? Anybody feels like they could not do this question?
Nah, it's simple enough.
Well, exactly, because they start you off nice and, with a nice little confidence boosting question. Something that lets you say, yes, I can do the programming, right? I can do the programming. Well, then they give you the question in French, because, French is the second language of Canada. So the next question here is that you and your friend have come up with a way to send messages back and forth. And your friend could encode a message. Encode David? Okay. Your friend can encode a message to you by writing down a positive integer n and a symbol. You can decode that message by writing out that symbol n times in a row on one line. Given a message that your friend has encoded, decode it. Okay? So the first line of input contains L, the number of lines in the message. So basically, take a look at the sample input that they give you. Take a look at the sample input that they give you, right? And take a look at the sample input and kind of work it out as you go along with it, right? So this first character here just represents the number of lines. The next L lines each contain one positive integer less than 80, followed by one space, followed by a non-space character. Alright? The output should be L lines long. Each line should contain the decoding of the corresponding line of input. Specifically, if line I plus 1 of contain, right? N space, right? Where of course N is the number and X is the character. Then line I of the output should just contain the character X printed N times. And then when we watch it, this is what they're asking us to do. They're asking us to read this character here, have a space, and then read this character here. Okay? How are we going to work this out? Anybody have any ideas? I think we know enough to be able to work this out, right? So the messages, don't try and make sense of the messages as something that, don't get caught up with, well, what the messages mean or anything. So study that you have the specification, and all you want to do is you want to be able to output the specification. So they said that the messages have a positive integer n, right? So this 9 here represents n, and then and of course you have a symbol after it, right? And that symbol is X. And you can decode the message by writing out that symbol X n amount of times, which is what they told us down here. And of course, the output should be the same amount of lines down here. So how do we do that? How do we do this?
So I kind of confused about this one. Just a little.
Why? What is confusing?
Now, like with the whole line, but I probably just need to like read over the question
Yeah.
again.
All right. Okay. Yeah. No problem. We can read it over again. Right. We have even this problem description. It don't really matter so much. The first line of input contains L. So this L, all this tells me is that my message is a certain amount of lines long. All right. And then the next L lines contains one positive integer that should be less than 80, followed by followed by a non-space character. We know how to do this. We know how to do this, and we know how to do this in C. Right? This here could be represented by a variable called n, and the character could be represented by so this here is int n, and this here is char x. How would I represent something in this format? How would I represent something in this format here? Right? This number of lines could tell me that I could do something for x is equal to 1 to L, step 1. I could do that, right? And this line here tells me that whatever L is how much lines I should expect. Yes?
Yes,
Yes,
sir.
sir.
Yeah? Right. And then what else can I expect? Maybe I could think of this as an array of numbers and an array of characters. Right? So n could be an array, and x could also be an array. You start to see where the problem solving coming in, because all we know is that whatever is entered, we have to print out this character this amount of times. We cannot do that. We cannot do that until after all the data has been entered. So how do we capture all the data? Maybe have n be an array so that I could capture n and capture x, and then afterwards get the amount of times x should print out from the n array. Anybody don't know what I'm talking about here? Or anybody not seeing where I'm coming from with the solution?
So,
Everybody just quiet.
so it's like if you want, like if you have an the size of the array is the n, and what inside the array is just the symbols itself and just printing out it that amount of times.
No, I have two arrays, I have two
Yeah.
arrays.
Okay. Yeah.
Right? Yeah,
Okay.
so I have two arrays. Let's assume that they're not going to put in more than 100 lines. So I could create these two arrays, all right? And once they put in a number here, I now start to put in the first line will go on the first index. So how do I get this information stored into my array following this specification? I could say scanf %d space %c and store my value in n at position x, right? Oh, sorry, not x. I shouldn't use x here because I've already have a variable named x. So n at position y here and store the next one in x at position y. You understand where I'm coming from with this?
So you're basically printing out the elements in X n amount of times from that array?
Yes. Where the indices match. Right? So what I'll end up with is if I start to look at it as a regular array, given my input, I have 9, 3, 12, and 2 stored in here. I have plus, minus, e, and x stored in here. And because these, right, so I could go 0 to L minus 1, right? When I reach down to do the output, I say, okay, read the number from this array n and print out x n amount of times where the indices match up. So the plus will get printed out 9 times. The minus will get printed out 3 times. The A gets printed out 12 times, and the multiplication or the capital X gets printed out 2 times. You are with me on this?
Yes, sir.
All right.
So yeah, so it's just one folder be using for that done, and just basically do one kind of printer
print out
statement, and you
this,
have it printed out on
no,
different lines.
this second line will require, and this output would require a nested for loop, because you will end up with 4. Y is equal to 0
Yeah, right.
to L minus 1, right? And then you would say for Z is equal to 0 to N at position Y minus 1, right? Print out X at position Y. Does this make sense? So I'm at position Y. Y now represents this value, this index for me here, right? So I'm saying for Y is equal to 0 to L minus 1. So when Y is 0, I would say loop 0 to N at position Y minus 1 times. Loop from 0 to 8, which is 9 times, and print out what's in this here 9 times. Let's take a look at it in the C code, okay? Let's take a look at it in the C code. So the first thing that we do, yeah, Joshua, ask the question.
Oh no, I wasn't going to say anything.
Oh, okay. So again, new file, save. We say 2019 CCC Q2.c. Right? And so this here is really an exercise about thinking on the spot, Right? It's really an exercise about thinking on the spot. So let me just open it up in my all right. Give me a second here. I just want to also have it open on my second screen so that I don't have to be jumping back and forth between the whiteboard and this. Right. Just to be able to remember the variable names, because I tend to forget things. Right. Peace. So. Right. So we have our everything set up. We need to have an integer array called n, right? And we could give that size of 100. We can have an integer, sorry, a character array called x. So we also have x and y, according to what I had on my whiteboard. Not x and y and z, right? As my variables that I use for my counters. So I have y and z as my variables that I use for my counters. So I say int, sorry, not int, char x is also 100, just to be able to have enough space to store my values inside of here, right? Now I know the first line that I should have is my sample, is my value for L as well. They asked us to use L to say the amount of line, right? They asked us for L lines, right? So they say the first line of input contains L, and that tells us how many more lines to expect. So I should say, as the first thing I should say is scanf %sign D ampersand L. Okay, and I'll comment this one, right? This tells us how many lines to expect. All right, and put a get char there just to be able to clean up input. Now this L dictates how many lines I would read again after that. So I start with a 4 and I say for y is equal to 0, semicolon, y is less than L, semicolon, y plus plus, right? And what does this tell me? This tells me for L amount of times. For L amount of times, what do I want to do? I want to read in a value, a numerical value, and a character value into n and x. So I could say scanf, and this is my format, %sign D space %C, because x is a character array and n is a numerical array. And I want to read it into n at position y, right? And I also want to read into x at position y, my character. So read the number, right? Read the code number and the code character into the array spaces. Right? And of course, they're separated by a space because our specification asked us to separate them by a space. And so this is the code that will allow us to read every character and say how many times I need to output that specific character. And now we move to, once this is finished, we have to output each line. So we say for, right? For y is equal to 0. For y is equal to 0, semicolon, y is less than L, semicolon, y plus plus. So again, for every line that was read, what do we want to do? We want to say for z is equal to 0, semicolon, z is less than what is inside of the array. at position Y. Z is less than what is inside the array at position Y. Z plus plus. Right? So for every for the amount of times at that position in the array and for the amount of times at that position, we go printf. Printf what? Printf percent sign C. Right? And what is percent sign C? The character that is in the array X. So X at position Y. Right? Print out that character stored in the array position at Y. And because we want each one on a new line, we have to say printf \n, right? And each time you print out all the characters, skip to a new line. And hopefully, this is our solution here. Hopefully, this is our solution here. Right? Yeah, getcha, sorry. Return 0. Hopefully, this is our solution here. So I want to put a getcha here because after every scanf, we should have a getcha just to be able to clean up the input that the computer reads. Let's compile. We have no errors in compilation. And what do we want? We have 4. We have 9 space plus, 3 space minus, 12 space A, 2 space X. And just like the specification asked, we get the same output. Any questions? Any questions so far? Comments? The code is not there.
This was
Right?
it was simple, sir. I can try it.
It was simple. What makes it look difficult is the fact that we don't really have very descriptive names for anything that we're using. But the code is actually quite simple. You know? So at this point, I'll take a little break. Right? We could take a 15-minute break, and then we would resume at 10:05 and continue on to question 3. All right, so I'm going to pause the recording now, and we will resume the recording when we start back for question 3.